Okay, so today we're going to talk about tangents, which is a word we already know, so this becomes kind of confusing. Which tangent are you talking about? Are you talking about these tangents or those other tangents? Today we're talking about these tangents, which is one of those. What's a tangent? Emily, you're up. What's a tangent? I'll give you a hint. It's not green.
A line segment, a point that goes through a point on a circle, on the edge of a circle.
Well, hold on. The edge of a circle? Do circles have edges?
No.
No. So you could just say on a circle.
Yeah.
There's one small thing that you said that I didn't like. Oh, I told you that wouldn't be any fun. It was in the very beginning.
Was it line segment?
Yeah, I didn't like that.
A ray?
I didn't like that either. I only got one other choice. It's a line. Good. It's a line that what now?
That goes through a point on a circle.
That's it?
Yeah.
You don't say anything else about it? Are we okay with that? No? What don't you like, Mr. Smarty Pants? Other than the fact that you just want to be negative.
It's just that, isn't it only 1 point?
Well, she said, a point.
Oh.
What did you think she said?
Yeah. Michael.
Yeah, really? Is that what it is?
It's really-
What, you're offering him a lollipop or something? So let me ask again, how do we feel about Emily's definition?
Good.
Like it? Okay. All right, let's see how you did, Emily. Not bad. Okay. Now, my picture said that it was a line because that's what we started with. But you'll see as we start looking at examples that you could have a line, array, or a segment. It gets a little tricky with the ray and the segment part of it because since they don't go on forever, you could argue that you would have something weird, like for instance, where's my, oh, I forgot I moved over here. If I do something like this, okay, there's a ray. That's not a tangent though. Okay, so think of the straight object as a line and you'll be good to go. Down at the bottom there, I have what's called a trichotomy. Trichotomy means 3 possibilities of how a line and a circle can intersect. Okay, they don't intersect. That's not very exciting. We have a tangent, which is what we're going to talk about today, and we've done this already. Well, we've done that already, the chord part of it. Later on, we're going to talk about something called a secant, which is a line that passes through a circle and hits in 2 points. Can a line hit a circle in 3 points? Are you sure?
No.
Yeah, so low.
It can't.
It can't
No, that's not.
unless,
2 lines.
wait. A line can only hit a circle in 3 points if it's 2 lines. What's wrong with you? I'm just going to move on. The biggest thing about a tangent is that we have this thing called the point of tangency. It's the point on the circle that the tangent line passes through. Anytime you have a tangent, it's going to hit that radius and form a right angle. Okay, that's got to be a right angle if it's tangent. If that's off even a little bit, it's all of a sudden going to intersect the circle in 2 points. Okay, so you just swing that bugger down just a little bit, and all of a sudden it's going to pass through the circle 2 points. We want it to pass through only 1 point. Which you can see that it's going to lend itself to quite a bit of Pythagorean theorem calculations. Which is exactly what I'm going to ask you. How long is AC? Let's go with an approximate answer here. We don't necessarily need an exact answer.
133. The square root of 133.
That would be an exact answer. It's not 133. 15? No. There's no 6, 13, 15 triangles. Oh yeah, there we go. Now we're getting the calculators out. You can hear the rustle.
It's more than 14 on this side.
It's not a pretty number,
Great.
because it's not a triple.
Where?
What do you got, Madeline?
14.32.
14.32, can somebody confirm?
Yes.
Beautiful. The important thing and the common mistake is, where's the hypotenuse?
CA.
A, B, B, C, or CA?
CA.
It is CA, correct. The common mistake is that people consider AB to be the hypotenuse, and that ain't the case. $14.3. Beautiful. All right, as I mentioned earlier, don't get these tangents confused with the other tangents. The other tangents were functions like add, subtract, multiply, and divide, sine, cosine, tangent. These are physical objects. It's a line or a ray or a segment. Converse of the theorem would then be, if you have a line that hits in one point, it's going to be perpendicular. The converse would then be, if you have a line that's perpendicular at that point of tangency, then it's got to be a tangent. So for instance, wow, that blue is not a good choice. If you can't see that, it says, is FR tangent to circle O? That's good. A light blue color on a white background. That's why I didn't go into art. Emmett, question.
So if it asks if it's tangent, does that mean Pythagorean theorem will work with it? Like if we use
I don't know. If I knew, I wouldn't ask you the question, would I? Molly, how big is the original gangster?
Huh? OG, Molly.
Oh, gee, Molly, come on.
I don't know yet. I just finished
Sure you do.
drawing.
Look at the picture.
Oh, 5.5.
Beautiful, thank you very much. That's kind of an important chunk of information. No self-injury. You learned about that today, right?
Yeah.
Self-love, not self-injury. You're gonna have to take away all the sharp objects?
No.
Okay, you're good. You're
Yeah.
gonna start stabbing yourself with that, are you?
No.
Okay, good. Yes, sir?
no.
No.
Agree.
Agree?
Yes.
Agree. Explain why.
13.6 squared plus 5.5 squared
Hold on, I can't write that fast. Plus 5.5 squared.
equals 215.21.
Wait, hold on. Set up the whole original equation. Then we'll do some number crunching there.
Equals OF squared.
And how
So
long is O?
15 squared.
15 squared. Okay, so notice I put the question mark up there because we're checking to see if it works. What's the left side equal?
215.21.
The right side I can do on my own, 225. Those are not equal, therefore not a right angle. Which means that FR is not tangent to the circle, because in order for it to be tangent to the circle, that guy would have to be a right angle, which we just showed. We have shown that it's not a right angle. Hey, Emmett,
What?
what kind of triangle is FRO?
A cube?
Well, you had a 50-50 chance.
What is that?
You want to stay with a cube, or would you like to take what's behind door number 2?
I want to stay with the cube.
You're gonna stay with a cube. Is he right or wrong?
Wrong.
He is unfortunately wrong.
Okay, I'm
Yeah.
sorry.
A squared plus B squared has to be greater than C squared for an acute. It's actually an obtuse angle. Okay? Beautiful. I just put it down. There's another one. Hey. I'll leave that for 8th grade. There we go. We're not going to do a lot with this. The reason I included this slide is because you should at least understand the understand the terminology. I'm using big words again. We have these things called common tangents, and a common tangent is a line that's tangent to 2 or more circles at the same time. There's two types. There's an external tangent, like is on the left, like that game Shoot the Moon. Everybody know the game Shoot the Moon?
Yes.
No?
The little track.
So yeah, the two rods with the big metal ball, and you gotta get to roll uphill.
No.
Okay, just keep saying no, Vanessa. With a huge tone of scorn in your voice.
No.
Like you're angry you were deprived of the opportunity to play Shoot the Moon as a child. No.
They always had it at the library.
And then, what?
They always had it at the library in like the kids section, and I was like always looking for it, and then one day they didn't have it, and I was really upset.
Poor
Because
big
I got really
sorry.
attached to that game.
Do you feel better now that you've cleansed?
Yeah.
Excellent. Good for the soul. On the right-hand side, we have common internal tangents. External tangents are on the outside. The internal tangents are on the inside. Internal. Okay. Let's try this. This will be fun. Let's do this. Whoa, that was a miss. Okay, that. And we'll label this X, and we'll label that Y. What kind of quadrilateral is XPQY?
Type?
What type? Yes.
Oh.
Parallel.
Not a bad guess. It's wrong, but not a bad guess. Trapezoid, but not a bad guess. Any others?
Is this a plot?
Yeah, it has 4 sides. It is a quadrilateral. You say just a quadrilateral? It's none of the others?
Yeah.
Okay. Not a bad guess. Any others? Is it a square?
No.
No.
Okay. Could it be a square?
No.
No. Can be.
No.
We'll come back to that question in a second. Is it a rectangle?
No. Yes.
No.
Just keep flipping back and forth between yes and no until you try to read my reaction. So if you say no and I'm like, but if I'm like, then switch over to the other one. Yes, it's a rectangle.
No.
No.
Yes, it's not a rectangle.
Correct.
No, it's not a rectangle.
Height.
Yes, it is a rectangle. That's not easy to do, by the way. Say yes and shake no. All right, so let's start with this. Let's suppose it is a rectangle. It can be, doesn't have to be. If it is a rectangle, what must be true in the picture? Have
2 circles are congruent.
beautiful. If it's a square, what has to be true? Have it?
All the angles have to be 90 degrees.
And?
The sides all have to be.
And how do we manage that with 2
The
circles?
2 tangents have to be parallel.
Yes, and? Just keep.
The opposite sides have to be parallel.
Okay, good. I'm sorry? Huh? What? Huh? I said,
I was thrown
do you have your
off
voice
the-
back?
I'm missing the key.
A little bit.
I understand. Go ahead.
Does the distance between the 2 circles have to be equal to the radius? Why? You're looking at me.
I'm sorry, go ahead.
Does the distance between the 2 circles have to be equal to the radius?
Yeah, good. Okay, so the important question is, what shape must that be? Okay, good. That's my fault. I'm gonna take the hit on that one. What quadrilateral, other than just a plain old quadrilateral, must that be?
A trapezoid?
It has to be a trapezoid. Could be other things, but it has to be a trapezoid. Why? Hold on to victory dance for a second there. Why must it be a trapezoid?
Because the 2 sides right there have to be parallel.
These 2 sides?
Not the other ones.
These 2 sides.
Yes.
Why must they be parallel?
Because they're both 90-degree angles.
Good. They're both perpendicular to the same line, which makes them parallel. Good. So that thing has to at least be a trapezoid. It could be a rectangle or a square depending on the size of the circles and how close the circles are together. Okie dokie. Tangent segments. So you take a point outside the circle, which you can notice now that things are going to get interesting because we started with a vertex at the center of the circle. We moved that vertex on the circle. Now we've moved that vertex outside the circle. If you draw two tangent segments to the circle, and there's only two, the segments that are formed are called tangent segments. What can you tell me about that ice cream cone looking picture? Dev?
It's a kite.
B-E-A-R is a kite?
Yeah.
Okay, so if that's true, then, well, I'll just ask the question straight out. How do you know that?
I guess.
Not a bad guess. Can you prove it?
Possibly.
Okay. You want to take a shot, or should I call on Chowderhead up here in the front row?
Go ahead.
What'd you call me? Goathead. That's uncalled for. All right, what do you got, Sparky?
If you draw a chord from E to R, you're gonna form like two isosceles triangles.
If I draw a chord from E to R, I have two isosceles triangles.
Yep.
Well, I have a big question about that. How do you know that one's isosceles? I'll give you this one. How do we know that's isosceles? Yeah, the radii are equal. All right, I'll give you that. I'm not giving you that one. How do we know that triangle EAR, ear, is isosceles?
This is like the
Because if we know it's isosceles, then EA is equal to RA, which means Deb was right and it's a kite.
Can I write
Just
on
because it's more fun to hear him talk. Right?
Can I like write on the board? 'Cause that'll be
What are you gonna write, like gang symbols or?
just a couple of lines and curve things. Dude, always wanted to write on the board.
You've never been up to the board before?
Well, I have once. But
Okay.
since this cuts angles at the same point, that means these two angles would be equal, and by that piece, those are equal.
Oh, wait, yeah.
Everybody follow that?
yeah.
That's one way to do it. I like it. The victory dance is a little unnerving though, but. Okay, so now we've established that EA is equal to RA, and therefore what Dev said is correct, it's a kite. But more importantly is the fact that these two things are equal, which you'll see on the next slide. The other way to prove this same thing, not that there's anything wrong with the way you did it, would be to do this. Wow, completely missed. Whew. Can I prove those two triangles congruent?
Yep.
How?
The line you drew is congruent to itself.
And therefore the triangles are congruent by?
Side, angle side.
Nope.
Angle. Angle side, angle.
What other pair of angles?
The same. I mean, ABR and ABE.
We don't know that ABR and ABE are congruent.
Wait.
You chill for a second. Morgan. Beautiful hypotenuse leg. That's actually angle side side, but it's a special case because we have a right triangle, which is hypotenuse leg. Both of those prove the same thing, which is what we're getting to in the next slide, and that is that tangent segments are congruent. Any point outside the circle, when you draw the tangent segments in, those tangent segments have to always be equal. If I move A in closer, the tangent points will move. Here's an interesting question. If I move A to the left, will E and R go this way or go that way?
That way.
This way.
Hold on, let's do this. If I move A to the left, will E and R move to the right or to the left?
Right.
They will move to the right, correct. What?
He goes this way.
What time's the bell ring?
In a minute. 30
Oh, beautiful, I'll talk fast. This is called a walkabout problem. You start with one segment or two segments and you work your way around the problem, or up around the picture. Stop, focus, wait. How long is CD? 9.5. How long is AD?
3.
Right, because there's a 3 there. How long is AE? 3. Could you find these two?
Yes.
How?
50.
Oh, add them all together.
Right, add those all up, call that X, set it equal to 50. And we, okay, so go.
Okay.
Day 6, I'll unlock it in a minute.
Go.